Hi everyone, I hope you are all doing well. We're going to continue our weightlifting for our brain on algebra, and we are going to talk about simplifying complex fractions today. And there's two ways you can approach this. One is to simplify the numerator and denominator separately and then divide fractions like we did 2 lessons ago. Or the way I'm going to show you kind of takes out that last step for us, and actually it's going to then be less work for us. So what you want to do is you want to find the LCD of all terms. So this is just over 1, and I want to find the least common denominator of all 4 terms. Okay, so the LCD of 1, 2, 4, and 20 is going to be 20. Okay, so once you find the LCD of all the terms, you are going to go ahead and multiply everything by that LCD. So you're going to multiply the top by 20 and you're going to multiply the denominator by 20. Okay, so if you need to do some work over to the side, basically this is 2 over 1 times 20 minus 3 over 4 times 20 all over 4/5 times 20 plus 1/2 times 20. Okay, and then you just simplify each fraction. So this first fraction is going to be 40 minus 60 over 4, which is 15. And then this is going to be 80 over 5, which is 16. And then 20 over 2, which is 10. So notice by multiplying by the least common denominator of the entire complex fraction, and by the way, a complex fraction just means that it's multiple fractions within a fraction. Okay, and so by doing that, we don't have to do the final step of dividing the fraction, so multiplying by the reciprocal. Instead, we can just go ahead and simplify. Okay. All right, let's do another example. Let's go down to the you try example. We'll go back up to number 2 in just a moment. Okay, so the first thing we need to do is find the LCD of all the terms. Okay, or should I say all the fractions. So find the least common denominator of 3, 6, 4, and 8. And in our case, that's going to be 24. So I'm going to multiply top and bottom by 24 over 24, so I'm not changing the fraction at all. So this first fraction is 1/4 times 24, which is just going to give me 6, plus we have 2/3 times 24, which is 48 over 3, and that gives me 16, divided by 3/8 times 24, which gives me 72 over 8, which is 9, minus 1/6 times 24, which is 4. And then go ahead and just do the math, and you get 22 over 5. Okay, so find the least common denominator of all the fractions, and then multiply and simplify. All right, let's take a look at this example. So these numbers are just over 1, and this variable is just over 1. So I need to find the LCD of all the fractions, so 1, y, 3, and 1. So the least common denominator of all of that is going to be 3y. So we have to multiply each fraction by 3y. So the first one is 2 times 3y, which is just 6y. The second one is 1 over y times 3y, which is going to give me 3, so minus 3, divided by y times 3y, which is 3y squared. And then finally, 1/3 times 3y, which is just y. Okay, so if you got this far, great. You did a lot of the right work. Do not make the mistake of starting to cancel these y's. Remember that addition and subtraction, they're connected and you can't break them up. So what you can do is see if it factors, which if you take out a 3, you get 2y minus 1. And if you take out a y, you get 3y minus 1. So nothing factors, and then this is your final answer. Okay. All right, let's go to the next page, and actually the last page of the notes. And once again, we need to find the least common denominator of the entire complex fraction. So this is just over 1, this is just over 1. So we need to find the least common denominator of all of these. So numerically, it's just going to be 1 and then x squared. So the LCD is x squared. So multiply top and bottom by x squared over x squared, so we're not changing the fraction. And then we just go ahead and simplify. So we're going to get x squared minus 2x minus 15 all over x squared plus 7x plus 12. Okay, if you're not sure how I did all that, I multiplied each part by this term. So 1 times x squared, that's how I got x squared. 2x times x squared, that's how you get 2x. And then 15 over x squared times x squared, that's how you get 15. Okay, and then same thing with the bottom. So this goes to each term. So 1 over 1 times x squared gives me x squared. 7 over x times x squared gives me 7x. And then 12 over x squared times x squared gives me 12. So now we have just a fraction and not a complex fraction. So we can go ahead and factor this. So x minus 5, x plus 3, all over x plus 4 times x plus 3. And hopefully you notice that we do have two things in common. We have a set of parentheses. So we cancel those out, and I'm left with x minus 5 over x plus 4. Okay, so find the least common denominator of everything, and then go ahead and multiply, and then just simplify, factor and simplify. All right, so I want you guys to do the try example on your own. So when you're ready to, you're going to hit pause, you're going to do the problem, and then see what the answer is and see if you get the right answer, just like we would in class. Okay? All right, go ahead and hit pause. Okay, we should have gotten x minus 3 over x plus 2. So let's go ahead and walk through this. So find the LCD of all the fractions, which is going to be x squared. Okay, multiply everything by x squared. So right here, that's going to be 1 over 1 times x squared, and that's how you get x squared. And then this one is 9 over x squared times x squared, and that's how you're left with 9. And then you do the same thing on the bottom, and that's how you get left with these three terms. And then see if you can factor it all. The top is dots, difference of two squares. And then the bottom, what two numbers multiply to 6 and add to 5 is 3 and 2. And then you guys can go ahead and cancel the x plus 3's, and this is what you're left over with. Again, please do not cancel these x's. You can't do anything with them because they love their partners, and you cannot break them up. Okay. All right, last example. So once again, these numbers are just over 1. And so look at each term or each fraction and find the least common denominator. So it's between m minus 2, 1, 1, and m minus 2. So that's pretty straightforward. The LCD is just going to be m minus 2. So multiply by m minus 2 over m minus 2. All right, and let's break this one down so we can see visually everything. So 2 over m minus 2 times the LCD. These cancel, and you're left with just 2. So we have 2 minus, and then for this one, it's over 1, so we need to keep everything. So m minus 2 divided by 3 times m minus 2. So if you want to do the work over to the side, you can, but that's just going to be 3 over 1 times m minus 2. So nothing cancels. And then minus 1 over m minus 2 times m minus 2. These cancel, and you're left with just 1. Okay? So, please, 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 you can't cancel these. Notice that there is subtraction here. So these terms are a pair, and these terms are a pair. You cannot break them up. So instead, we need to go ahead and simplify. So 2 minus 4m plus 8 all over 3m minus 6 minus 1. And that gets me negative 4m plus 10 over 3m minus 7. Okay, and technically you could take out a negative 2 out of the top. So I could do negative 2 and then be left with 2m minus 5 over 3m minus 7. But that doesn't change the problem, the answer, because none of this cancels. So either one of these answers is acceptable. Just careful up here that you don't accidentally cancel these m minus 2's. Okay, this is if you want to put like big parentheses or brackets, these are pairs. You can't break them up. Okay. All right, kids, we only have one more workout of the brain left for the videos coming in a few days. Other than that, you guys, thanks so much for watching. I appreciate all of your hard work. Stay strong. We can do this.